Many ionic compounds contain polyatomic ions. Use the same rules for writing formulas and naming as we did for ionic compounds with monatomic ions in an earlier video. I'll link the video in the description. For polyatomic ions, there is one caveat. Because polyatomic ions are a group of atoms, we must include parentheses around the polyatomic ion only if there is more than one. Before moving on, let's review polyatomic ions. Polyatomic ions are groups of atoms covalently bound that contain a net positive or negative charge. Most polyatomic ions we'll see in general chemistry are anions with an occasional cation. Nitrate, acetate, and carbonate are examples of anions, and ammonium is an example of a cation. Here are ammonium nitrate, calcium carbonate, and magnesium acetate. For each example, I'll identify the ions present first. Notice the charges of +1 on ammonium and -1 on nitrate and acetate. The coefficient of 1 is generally omitted because 1 is understood. Next, we'll use the Criss-Cross method, which is commonly taught in every chemistry course. We'll crisscross the coefficients and insert the values as subscripts. The subscripts tells the reader the ratio of ions. Again, note how I have omitted the subscripts of 1. They are understood. For ammonium nitrate, the empirical formula, or simplest whole number ratio of ions, is 1:1. No parentheses are needed, and we can write NH4NO3. For calcium carbonate, the ratio is 2:2, but this can be simplified to a 1:1 ratio. No parentheses are needed, and we write CaCO3. Finally, for magnesium acetate, the ratio is 1 magnesium ion to 2 acetate ions to balance the charges. Here, we'll include the parentheses around acetate to indicate that there are 2 ions of acetate for every 1 magnesium ion. And the formula is Mg, open parentheses, C2H3O2, close parentheses, subscript 2.